Hey class, hopefully you were doing quite awesome on this wonderful day. This is our kind of like introductory video or just going over this lab for our Golgi tendon organ and post-activation potential lab. So as always, let's go and just explain what you're going to be turning in. So a short video of yourself doing the different parts of the test, or a multitude of pictures proving to me that you actually did do this test. And as always, the worksheet at the very end, which on here I believe is page like 7 or 8 or something ridiculous like that. Um, there's That's about all I'm gonna actually ask you to turn in. This is a pretty fun test, and let's go ahead and get into it. So the background on this. Really, if we're thinking about what we're trying to alter or augment here, is your muscle's ability to acutely exert force. So overall, that's really what a post-activation potential is. So doing some type of physiological manipulation, typically to our proprioceptors, or kind of exciting our nervous system. So our proprioceptors being our Golgi tendon organ and our muscle spindles. I'll talk a little bit more about that momentarily. But this post-activation potential, really all we're trying to do is increase motor unit recruitment, muscle spindle firing activity, synergist musculature. So the main muscles we're going to be using in this are the hip extensors, so like the glute maximus, and also, the knee extensors too, so the quads, so that we can acutely increase our performance output so that, maybe we could use that in warm-up protocols so that we could actually have more of a training stimulus whenever we exercise or what have you, right? So these Golgi tendon organs, let's go and talk about those just a little bit. Hopefully you already know what these are. Effectively, all that they're doing is sensing tension within the muscle. And then, whenever they sense an excessive amount of tension, these are really just trying to protect your muscles and tendons from injury. And whenever they sense an excessive amount of tension, there's going to be, a signal, this afferent neuron coming back to the dorsal root of, the um, like spinal column and all of that, and then it's going to send an inhibitory signal. Man, that's hard to say. To our, efferent, alpha motor neurons, so that you actually can't send a signal anymore to contract. And that's broadly called, this term right here, autogenic inhibition. So we'll come back to that momentarily. So this Golgi tendon organ, just remember that all it's really trying to do is protect your joints. Really, same thing with the muscle spindle. Now, this investigation that we're doing, we're not really manipulating the muscle spindle too much. Now, we could do that if we say try to do a jump. That's what we're going to be doing later. Hopefully you've read this lab before you're watching this video. But whenever we're doing the jump, we could test our muscle spindle by doing a really good long paused jump. So, like bend your, knees 45 degrees or whatever, wait for a full second, and then jump up as high as you can, or have a rapid, what would be called a counter movement jump, where you start upright, you dip down really quick, and then you go up. Because what that would do is that would trigger the muscle spindles to where there's a very quick lengthening of the sarcomeres, and then that's going to send a signal um, back through the nervous system to the alpha motor neuron to have an increased output. This is frequently called the stretch reflex. One of the reasons why, if anybody has ever like squatted quickly or whatever, if you ever like in powerlifting, we used to call it dive bombing. So if you would have a really fast eccentric, a really fast lowering, a lot of times you would bounce, as we would say, out of the hole of the squat, because if you've ever done any powerlifting, you have to kind of go excessively low to prove that you've squatted quite deeply. And that would be one way that we would actually kind of circumvent that difficulty at the very at the very end of the range of motion, more or less. So there's that. Now, why is some of this stuff important? Whenever we are beginning some type of strength training protocol or really trying to adapt in our maximal ability to exert force, which really is important for just about everybody, from the elderly to strength athletes to even endurance athletes. There's quite a bit of research showing that the stronger an endurance athlete is, the better their running economy, and so on and so forth. It's really good research out there, and if you want some of that research, there's a lot of cool stuff out in Norway I could send you. Just email me and I'll send it to you really quick. But at the beginning of a protocol of trying to adapt, most of our adaptation is actually neural. So there's a lot of stuff going on here, like better motor unit synchronization. Like the different motor units will learn how to effectively depolarize in the most optimal fashion so that we can more effectively move a weight or move our body or whatever. There's also better rate coding. We develop a little bit more myelin sheaths, stuff like that. But also, this autogenic inhibition stuff is quite a bit, that we can kind of desensitize our Golgi tendon organs to the amount of stress, because if you're having a high force output that your muscles are not accustomed to, your body is effectively just going to perceive that this is too dangerous, it's trying to kill you, all of that type of stuff. So it's going to prevent you from contracting as hard as you possibly can. Now, we can train through this, or we can do little augmentations so that we can actually, like, circumvent this, or I'm using that $5 word yet again, so that we can like have a better training stimulus and potentially quicken up this neural learning phase so that we can start getting into like hypertrophy phases or whatever. So there with autogenic inhibition. Here I just wanted to like have a little bit of kind of a review of what some research has shown in the past. So this is looking at manipulation of kind of the musculotendinous unit and the nervous system overall, right? So prolonged stretch of muscle spindles inhibited their afferent activity, which resulted in a decrease in muscle tension. So this is one of the ideas where we get, if you do static stretching before something, then that's actually going to inhibit our ability for maximum force output. Now that is really only in synergist and agonist muscles. And you'll see with the protocol that we're doing, we're actually going to be stretching the antagonist muscle so that potentially we could, for lack of a better phrase, deaden that so that our hip extension is a little bit stronger. So that's one of the ideas behind what we're going to be doing later on. So prolonged static stretching induces responses in Golgi tendon organs and nociceptors or pain receptors, which inhibit muscle tension. Now, these next two things are actually really interesting to me. There have been reported decreases in muscle elasticity of muscle connective tissue, thereby increasing extensibility. So if you don't know much about this, muscle elasticity is effectively the muscle's ability to be stretched and then rapidly come back to its original form, so effectively like a rubber band, so decreasing that retraction rate. And here, increasing extensibility. Extensibility, that just means its ability to effectively be stretched, if that makes sense. There's a few other functions of like skeletal muscle, like irritability and plasticity, things like that, meaning it can like get innervated and it can also change. So there's that. Maybe increasing acute extensibility, so its ability to, be stretched. And if we really get into what stretching is kind of doing, it might just be modulating our pain sensation. Next one right here, sarcomeres and tendons are acutely lengthened when stretched, which may persist for a time, thus altering the length-tension relationship that would diminish maximum contraction tension. So what that is, I think everyone knows this, that we have a optimal length tension relationship. So if you've ever been doing curls, for example, they're really hard at the very bottom, like whenever your arms are at your sides, but it gets progressively easier the more, contracted or flexed that your bicep is, because, effectively there's just, more actin-myosin cross bridges, things like that. So here's an idea that stretching might actually temporarily extend the sarcomeres a little bit and the tendons overall, so that there's actually less touching. So maybe that's part of what's going on. Now, this other thing right here, one of the, I don't know if it was the very first study for post-activation potentials, but it was certainly it's one of the more well-cited ones, that acute plyometric training prior to exertion can enhance power output. And this is actually where we're getting part of our protocol today. So what they're doing is drop jumps or depth jumps. I forget exactly how they're doing that, but effectively you're standing on a box, not really jumping off of it, just stepping off and letting gravity accelerate you down, and then once you hit the ground, jumping up. And that might actually decrease our autogenic inhibition, it might increase our post-activation potential, increasing synergistic firing of all of the other muscles that are assisting us in hip extension. So that was done in, I believe it was, yeah, it's elite sports athletes, which go that study if you really want to read it and check it out. So the equipment that you're going to need for this study isn't that much. You're just going to need a tape measure and like your phone or something to video yourself doing this. So effectively, what we're going to be doing, this is going to take 2 days to do. So with at least 48 hours in between, I don't want, well, I want you to have like really high jumps in this, as high as you possibly can. So on one of the days, and it doesn't really matter what order, you can flip a coin. One day will be the depth jump day, and the other day will be the hip flexor stretch day. So on both of these days, I want you to warm up for at least 5 minutes, ideally 10, by jogging, jumping jacks, whatever you need to do to increase your blood flow, increase your heart rate, all of that type of stuff. And then with a tape measure taped up against a wall, you'll see a video of myself doing it, and I really just took pictures of the video. Taped up against a wall, and I want you to practice jumping as high as you can, at least 3 times, and then rest for 2 or 3 minutes whenever you're ready to go, and then do your pre-jump. And then after that, we'll do either our depth jump protocol or our hip flexor stretch protocol, and then you'll do a post jump, right? So here is just kind of me explaining how to do the jump that we're doing. I want you to do this without your arm movement, but if you watch the video that I did it with arm movement, so I'm fine if you use your arms. If you use your arms and don't wait for a full second at the bottom, then you will jump higher. So just make sure that whatever you're doing in the pre-condition, you're also doing in the post-condition. So there we go with that, right? This is the formula we're going to end up using to calculate like our power output, our peak anaerobic power in watts. So this is the Sayers formula. It comes out of the study in 1999. It seems relatively good. It's pretty simple. 60.7 times your jump height in centimeters plus whatever that is, and then multiply that by your body mass in kilograms, and then you subtract 2,000 or so off of it. And here's a little bit of an example. I'll type this into Excel so you can see it later on. So effectively, this is all that you're doing. So if you want to be paused at the bottom and then hop up, you would just go from here, wait for a second, then jump up to there. Or if you want to do this, counter movement, go down, and then come up, effectively that's what you're measuring. So this, if we get really close to it, this is really all I want you to do. So you see I've got this tape measure going up against the wall. Make sure it's completely vertical, right? Otherwise that won't be super correct. And you know, like there's my knee, and then jump. And really it's best if you video this in slow motion so that you can really see where it is, and you might have to fiddle around with this a couple of times so that you can actually see this clearly, because you know, like 23, 24, 25, 26, 27, all of these different types of things, and all of that's in inches, so we're gonna have to convert that later on. And if you take a video of it, you can check out my video here. I don't know if you know, but you can go down here and alter like the resolution of the video and also decrease the speed. So I think whenever I was checking this out, I was looking at it at 0.5 speed or 0.25 speed, whatever one of the slowest ones is for you to be able to see it. So you can go check out this video, just copy that, paste it in if you want. You don't have to because, well, as you can see, the video is a second. So that's really the crux of it. So here are the depth jumps that you're going to do. You need to find a box. You need to effectively fall off of it. Well, not fall, like land on your feet, bend your knees, and then jump, right? So you're going to need to do that at least 10 times. So just for clarification, you're going to warm up, practice the jump a few times. Once you're done practicing the jump, then you're going to do your pre-jump and record that. Write that number down. Then, once you're done with that, whenever you're ready, do your depth jump. Do 10 of them, and then rest for around 2 minutes, you know, 2 to 3, something like that, and then perform your post jump. And then that post jump, video that, measure it, all of that. That's where you're going to get your post value. Same thing for this hip flexor stretch. So you're going to warm up, do your pre-jump, then you're going to hip flexor stretch, 2 minutes per side. You know, we're trying to really stretch the iliopsoas, all of those muscles right there, and you know, stretch it out. Try to increase your range of motion throughout the 2 minutes. You know, there should be a point after about 30 seconds in that you relax a little bit more and you can go a little bit deeper into the stretch. And then do both sides, and then after you do both sides, wait another 2 minutes or so, and then do your post jump. So hopefully all of that makes sense. Okay, so this, you need to insert your table from Excel, and I'll show you a little bit of everything going on here. We're going to have to make a line graph. There should be 2 lines on it. Anaerobic power output, watts, y-axis, and trial on the x-axis, right? And then tell me percent increases of the depth jump and the hip flexor jump, and there you go with that. I'll show you how to do all of that in Excel at the end of this video, because I know some of you are pretty good with Excel, so you don't have to watch it if you don't want to. Okay, then here, which intervention had the largest impact on vertical jump, and how could we use this for different individuals? Next thing, please read this paper, which I should have it linked to you. This paper right here, it's a really interesting paper. Really interesting. Not super long. It's a pretty easy read, and well, there we go. But this would also get you to it as well, this link. So, yeah, Roxanne and Lynn. So, Cool stuff there. All right, so let's go ahead and check out how to do some of this stuff in Excel, right? So if you don't need any help doing this, don't worry about it, not one bit. So uh, first thing to do, write your name, me. Weight in pounds, 170. Then let's go and enter that. So D1, wherever that is, 2.2046. Hopefully you're used to that number by now, right? Um, these values equals whatever the inches is multiplied by 2.54. That's going to give us the centimeters. So I just put this in right here so I didn't have to go back and forth, right? All right, so equal sign, right? So 60.7 multiplied by jump height, right there, then plus 45 point, man, multiplied by body weight in kilograms, and then minus right there. So yeah, that's interesting how that works. Oh, and here with that, let's go ahead and put the dollar signs around that value so that, I can just drag it down right there. All right. Here, no fill because that looks ugly, right? And here I'm gonna drag that down, and I'll just drag that down to no fill, right? That's what I wanted to do. And also delete those. Okay, so let's say that initially I jumped 12 inches, and then I jumped 18 inches, and then on to over here, let's say I jumped 11 inches again, or, some about like that, but it was 19 right there. So, this here, let's make sure that this looks right, 60.7 multiplied by that, 45 multiplied by body mass, kg, yep. Yeah, so that should be approximately right. Okay, so that's effectively how you could make that work really well. The part where I'm asking for these percent increases, let's look at that. So what you would do is you would effectively take the post, divide it by the pre, and then right here, that 1.28, that means 28% increase. That's what that means. And so let's do the same thing there. So 39% increase. So that's how that works. Next thing, let's go ahead and make our line graphs. So right there, insert, just highlighting that. So we have that right there. Now we're going to want to add that as well. So let's add it. So select on that, then we click on select data. Then over here, this legend series, so series 1, we can add this, and like we can name the series, so HF maybe, and then right there, we'll take that out, highlight those two, done. And then that series, we can edit it and call it DJ. And then here, pre, post. And then so I just added a, what is that called? A legend. Peak anaerobic power. No, not post-activation potential. Okay. Um, Peak power, watts. There we go. And then you would just copy and paste that in there. That's how you would answer all of those aspects of this. And let's go back to over here. Yeah, just answering a few of these questions. And that's really about it for what I want us to do. Okay, cool. So if you have any issues, please email me, let me know. And that is about it. Thank you so much.